And alcohol phenol ether. You know about the alcohol when OH is present and naming is also there. More important is uh, when you see glucose also contain alcohol. You do this in the biomolecule that in case of glucose, you have multiple OH group. I asked one question about this from your biomolecule of chemistry chapter that what are the functional group present in the glucose? And Jordan, what you said, what are the functional group other than alcohol?
Alcohol, aldehyde, and
Carbonyl.
carbonyl.
Carbonyl was one of the option. Okay. If you see biology part again, plant have cellulose. Cellulose is a homopolymer. Cellulose made up of beta glucose. Glucose again made up of alcohol. It means cellulose contain alcohol. You know about the primary, secondary, and tertiary alcohol attached to one primary, two secondary, and three tertiary. To distinguish this, we will discuss about the Lucas tests to differentiate between the primary, secondary, and tertiary. Tertiary is highly reactive and primary, like very less reactive. Same like allylic, uh, halide and benzylic halide, you have allylic alcohol. When alcohol is attached to the carbon next to the double bonded sp2 carbon. Same benzylic next to the benzene ring. Vinylic directly to the double bond and arylic directly to the benzene ring. Okay? Directly to the benzene ring. Here we have some special name. Example, when you have on the second carbon CH3, it is isopropyl. And alcohol definitely is there. But if other than the uh, second carbon you have CH3 group, then it will be known as the iso. So isobutyl alcohol. Four carbon in the straight chain. Uh, it is when CH3 is present on the second carbon, it will be known as iso. Other than second carbon, it is sec. So what is sec? Other than second carbon, if you have CH3, sec. If you have CH3 on the second carbon, it is iso. ISO is also included in the IUPAC name, but SEC is not included. Okay. So in alphabet order, you will also consider I of ISO. You already know about the tertiary structure and neo structure. Chandana, what is the difference between the tertiary butyl and neopentyl?
Sir, can you repeat the question?
Tertiary butyl and neopentyl, what are the difference between these two?
Sir, in neopentyl, there is extra CH2.
In neopentyl, one carbon is quaternary, attached to four carbon, and then you have some functional group that is neopentyl. Tertiary, as the name suggests, it attached to three. That's why this is tertiary carbon. Here you had quaternary carbon. Next to the quaternary, there is some functional. That's why neopentyl condition. You can have neopentyl halide, neopentyl alcohol, neopentyl amine, anything like that sort. Uh, Next, Barinder is there. Barinder, is she there? Pratigya is there, not Barinder. Pratigya, can you speak?
Yes, sir.
So, tell me what are the example of fatty acid and what is the maximum number of carbon present in fatty acid?
I don't know.
You don't know. Palmitic acid and arachidonic acid given in biology biomolecule chapter. Palmitic acid and arachidonic acid.
Yes.
Jordan, what is the number of carbon in palmitic acid?
So can you repeat the question? So I couldn't hear you.
What is the number of carbon in those two acids?
In palmatic it's 16, arachidonic is 20.
Yes. So here carbon is 16. Here carbon total number of carbon is 20. And what is the another name of glycerol, Tuhina?
Trihydroxypropane. I forgot.
Yes. 3-hydroxy. That's why trihydroxy propane. Just give me a minute. I will send this PDF. Go through it once. Let me send, because these name will help you in the other chapter also, like catechol. You know catecholamine. So Sarah, what is catecholamine?
Not sure.
Chandana, what is catecholamine?
No, sir, I'm not sure.
Catecholamine are emergency hormone, fight and flight hormone. Catecholamine. So those adrenaline and noradrenaline are catecholamine because they have catechol along with the amine, and this is the catechol. OH at ortho position. Cresol, it is like toluene plus alcohol. Cresol. Phenol used in the treatment of malaria, given in the last chapter also. And here you have two ketone like system along with the benzene ring. And so these are the common thing we use, the common name we use. Phenol used both in the IUPAC and common name. This is important because given in the NCRT, IUPAC and common name is same. Just give me a minute, go through it once. So ether we were talking about. How to decide the IUPAC name in case of ether? Oxygen will go with the smaller molecule. Example, out of two option, you have three carbon on one side and one carbon on another side. So what will happen if you say oxygen will go with the smaller molecule with one carbon? That's why you have one methoxy and then propane or methyl ethyl propane. Here we have one thing. One side you have six carbon, on another side you have seven carbon. You know oxygen will go with the smaller molecule, that is six carbon. That's why one phenoxyhaptane. Correct. Next, if you have two option, left hand side you have six carbon, right hand side also you have six carbon. Now you will give priority to the side chain, this part. Okay, and benzene ring will be the main chain. Benzene ring will be the main chain. Same here. If this name is really, really important. One side you have ethyl, another side phenyl, and this name is phenol, phenetol, sorry, phenetol, phenetol. So you have phenetol in this case. So one question was asked in JE, what is the number of sigma and pi bond in case of phenetol? So what you see if you know the name of the phenetol ethyl phenyl ether, then you know phenyl have 3 pi bond. That's why there will be 3 pi bond and remaining will be sigma. Sigma bond you can count. Any doubt, guys? And all these the IUPAC name given in the NCRT. Last, if you see one side you have methyl, another methyl, and another ethoxy. Correct? So two will be ethoxy, then one dimethyl side. Okay? Because you know alkyl and ether and halogen act as prefix always. It means here also it is acting as prefix. Not only here, wherever you are seeing, example, if you see this word hexoxy, so oxy is present in the prefix form, not suffix. Always prefix. Always prefix. Next, if you see the bond angle in case of alcohol or in phenol, in case of alcohol or phenol, if you see the bond angle, you can see bond angle is slightly more in case of phenol. Chandana, why? If you see bond angle in case of phenol, it is 109. Bond angle in the alcohol 108.9. So slightly it is more in the phenol. Why? And if you see
Because of repulsion.
because of electron repulsion, you have electron cloud in case of benzene ring, and you have lone pair on the oxygen. So this electron cloud and lone pair will repel and angle will slightly increase. Jordan, why bond length is more in case of methanol compared to phenol?
So because of resonance, that's why like the bond length in what is this? Phenol will be comparatively lesser. There'll be more pulling effect.
Yeah, partial double bond because of the resonance will reduce the bond length in case of phenol. Partial double bond in case of uh, benzene ring will reduce the bond length. Got it? So Hina, why there is more bond angle in case of ether?
Sir, because of the repulsion.
Repulsion between the alkyl group.
Yes, sir.
Sarah, if you see bond length in case of carbon-carbon single bond is more and triple bond is less, what is the reason?
Sir, electronegativity.
Electronegativity and their hybridization.
Mm.
Electronegativity and hybridization. Because of the triple bond, there is a maximum electronegativity in case of alkyne. It is sp. So when there is a triple bond, strong bond and bond length will reduce. Chandana, what happened in the carbocation rearrangement? If you are adding H2O in the alkene, so at one place OH should add, another place, hydrogen should add. Example, OH added here, hydrogen will be added here. Okay. But what will happen when you add acid in this? Carbocation will form. Carbocation always want to become like in a way where it have maximum side chain. Example, if you see here in this diagram where you have secondary carbocation, and in next diagram you have tertiary carbocation, and you know tertiary carbocation is more stable. Tertiary carbocation is more stable. Okay, that's why you have this table. And if you are having organic chapter, more or less you always get this carbocation rearrangement question. You must have seen in any of your exam, isn't it? Chandana, Jordan, because Jordan, you wrote more exam.
Yes, sir.
You have seen this 1 to hydrogen shift.
Yes,
Yes, sir, the methyl
methyl
for
also.
stability.
Hmm. Then alcohol preparation, how we can make one from the alkene. In alkene, if you do hydration, we just did this in this case. If you add water, OH will be added at one carbon, H on another, hydration of alkene. Second, we have hydroboration oxidation, exactly opposite to the hydration of alkene. Because in hydration of alkene, you have Markovnikov rule. In hydroboration oxidation, it look like anti-Markovnikov. Second, you have carbonyl, where aldehyde, ketone, ester, carboxylic acid, these can produce alcohol. Example, aldehyde or ketone after reduction can produce alcohol. And one Grignard reagent, this is also given in the NCRT. One of the most popular reaction mechanism is also given in the NCRT, and mechanism is important for your board exam as well. You have acid act as catalyst, and in the presence of acid catalyst, you are doing hydration, addition of water. When you add water in presence of H positive, what will happen? OH, which is more substituted, will be attached, and this reaction is known as acid catalyst. Okay, reaction is very simple. You add water and alcohol will produce. What is the mechanism? Because um, you can be asked what is the mechanism of this alcohol formation. So whenever you take alkene and you take water, what will happen? It will form the carbocation. Now you have to look which carbocation is more stable. Secondary carbocation is more stable than the primary one. And if you have to choose among these two, then definitely you know secondary is more stable. Secondary carbocation is more stable. That's why first one will be preferred. First one will be preferred because of the stability. And from the resonance topic, you know the rule of stability. If you want to check stability, you can check energy. Stability is inversely proportional to the energy. Stability is inversely proportional to the energy. More energy, less stability. Same, inversely proportional to charge. More charge, less stability. Octet. If you have a stable octet rule, more stable. Correct? That's why if you take here you have secondary carbocation, and here you have primary carbocation. And you know secondary carbocation is more stable than primary carbocation. Secondary carbocation is more stable than primary carbocation. Okay. Next is the nucleophile attack on the carbocation. You have two type of nucleophile: negative charge nucleophile and neutral nucleophile. Okay. When carbocation react with the water, what will happen? Water will be added, and then it will undergo deprotonation means removal of the hydrogen. Why? Because in first step you have protonation. Protonation means addition of H positive. Then water addition, and third step is removal of proton. Why? Because proton is acting like catalyst, so it will not involve in the reaction. It will utilize and then it will come out. Ultimately, no use. Only act as catalyst. So these are the steps in case of uh, hydration of alkene. First, uh, protonation. Second, nucleophile attack, and third, deprotonation. And this is very popular mechanism for your exam. Hello, hello. Any doubt, guys?
No, sir.
So, if you are going through this, you will get to know कि you need to know about the GOC properly. Hello. Hello. नींद आ रही नींद आ रही नींद इसका मतलब समझा दो नींद का मतलब नींद जो तो बात सुनी थोड़ा थोड़ा नींद आ रही है नहीं बात तो मेन मुद्दा की बात यह है कि पढ़ना ना उधर मैंने वो पूछ लिया था वहाँ भाई नन्नो आजाद जाओगा ये वो था ये मैंने तब तक कह दिया तब तक मैं कहना था उसको ये बंदा है ये बंदे नहीं कहता तो नहीं फिर एक बार होता एक बार बताओ अरे सुन तो ले मेरी बात अरे मैंने दे रहता हूँ बड़ी बुरा बंदा लेकिन तो एक बात बता कि मैंने मैंने तेरे से कह दिया था मैंने कह दिया कि तो फिर मतलब बुरा लगता है मैं समझ तो बंदा लगता नहीं मेरी भी तो सिर्फ सिस्टम था मेरे डिसीजन भी तो मेरे होने चाहिए तो मैं फिर वो तो भाई बात नहीं हूँ एडिट हो गया वो बने मैं बताऊँ फिर हुए है वही ठीक है तो तेरे भाई की फोन भाई की फोन लीजिए और बात करते हैं। Then guys, hydroboration oxidation, very popular reaction because this hydration acid catalyzed hydration is following Markovnikov rule. Opposite to this, you have hydroboration oxidation, anti-Markovnikov rule. Why? Because you are making alcohol in the same way. But what is the difference? OH is attached to the primary carbon, not secondary. A reason. What is the reason? Here we don't have carbocation method. In last situation, you were having nucleophile. water. Here we are using electron deficient molecule BH3 borane. And because two molecule, that's why diborane. So it is electrophile and incomplete octet. So it want to attract more electron toward it. By the way, this diagram is given in the 11th class. Keep diborane look like this molecule. And because they have shortage of electron deficient or acidic in nature, so they want to make bond so they can form the dimer and octet rule because they want to become stable by forming octet. What happen when you use diborane? It look almost like this for the basic understanding. Ki, you will add hydrogen and BH2. So BH2 will be added here. Then if you take more number of molecule of alkene will keep on adding and you will keep on removing the hydrogen like this. Ultimately, if you take two molecules. Okay. When no hydrogen is left, what to do? You take same water, but now in the presence of hydrogen peroxide. Does it something look like peroxide or Cross effect or anti-Markovnikov rule, Tuhina?
Sir?
Because here also you are using peroxide S2O2.
Yes, sir.
Okay, so it look like anti-Markovnikov rule or Cross effect or peroxide effect in presence of peroxide. Here also we have
Yes, sir.
peroxide. All right. So what will happen here? You will attach OH at the first carbon. But if you look at the first situation, OH will be attached on the middle carbon, second carbon. Reason? In acid catalyze, you have Markovnikov rule. Hydroboration oxidation, you have anti-Markovnikov. As simple as that. Everything else is same. Anti-Markovnikov rule happen in presence of diborane and H2O2. So hydroboration oxidation. Okay. H2O2 is oxidizing agent. Why it is oxidizing agent? Because it release oxygen. If it release oxygen, it means it will cause oxidation of other and reduction of itself by releasing. That's why yield in case of hydroboration oxidation is really good because more oxygen is released, cause oxidation of others. Correct. This is the basic introduction given from the redox chapter. Key compound can undergo oxidation and reduction. How to know? If any compound have maximum oxidation number like KMnO4, K2Cr2O7 or HNO3 or H2SO4, in all these compound, element is present in the maximum oxidation state. Like manganese have maximum oxidation state +7, chromium have maximum oxidation state +6, sulfur 6, nitrogen maximum oxidation state. When you have maximum oxidation state, only reduction is possible in such situation. Only reduction is possible in this situation, so it is oxidizing agent. All these are oxidizing. When you have minimum oxidation number, only oxidation can happen in such situation, and you will have reducing agent. You will have reducing agent. Example, here you have iodine, I negative, and it will convert into I2. So what is happening? Iodine was present in the least oxidation state -1. Then it convert into 0. So oxidation. Example, if you have oxygen in -2 oxidation state, oxygen cannot have less than that. So it can undergo only oxidation because reduction is not. If middle oxidation number, both are possible. Example, if you have K2MnO4, manganese is present in +6. It can convert into +7 and +2. both oxidation and reduction can happen together. Third reaction, oxymercuration, demercuration of alkene is not given in NCERT. This is not given in NCERT. What happen in this case? If you take alkene and you do oxymercuration in presence of mercury, oxymercuration, you have mercury acetate, okay, in presence of water. So what will happen? First, OH will be added, like Markovnikov rule, and then you will do demercuration. You will remove mercury. You will remove mercury. That's why demercuration. That's why demercuration. So in demercuration, what will you do? You will remove this mercury acetate, oxyacetate. So you are removing mercury, demercuration. So it look exactly like acid catalyzed hydration of alkene. Almost like. Why? You have water. Method is same. Markovnikov rule is follow. What is the difference? Only mercury thing are used. Mercuration and demercuration is happening. Otherwise, everything else is same. Tell me, guys, how is it going? Is it going good, or you are feeling it is too much? Guys, am I audible?
Yes, sir.
So send your notes in group. If you missed anything, you can utilize the same PDF. I can wait, finish what I taught till now, and send me your notes.